I made this video because I want you to review the material. I also made you the worksheet. You can pause the video at any time to fill in the worksheet. Alright, Earth moves through space in two major ways, rotation and revolution. You need to understand the difference in these. When we talk about revolution, the Earth is revolving. It's turning on its axis. The axis is this imaginary line right here. I've got an image of that. Whenever you hear revolving or rotation, I want you to picture this in your mind. The second way it moves is revolution. It revolves around the sun. Revolving around the sun means that it takes 1 year to go all the way around. Alright, we got a graphic organizer explains it. Here's the Earth on its axis. It rotates. It revolves around the sun. On its axis, when it rotates, this causes night and day, and when it revolves around the sun, this takes, well, they say years, but it takes a year to do it. Alright, sun striking the Earth's center. This is part of the reason for seasons. We get less direct sunlight in the northern and southern hemisphere and more direct sunlight on the equator. Now, Earth has seasons because it's tilted as it revolves. Let me go back. Here, you can tell that this is winter time because the North Pole is pointing away from the sun. Here you can tell this is summer because it's pointing at the sun. Some people had some difficulty on this. As it comes around to go from summer over to winter, it has to go through fall, and then from winter to summer, it has to go through spring. Now, the height of the sun varies above the horizon, which varies with the season. Because it's up higher in June, we get more direct sunlight, and because it's lower in December, we get indirect sunlight and colder temperatures. Got something to show you here. This is actually very good. What I need to do is adjust the angle of inclination. Let's take it to about 25 is about right. Okay, right about there. All right, check out the Earth. When it's here, average daily temperatures in the northern hemisphere are cold because it's pointing away from the sun. If I bring it over to here, where it's pointing at the sun, notice my temperatures increase nicely. And when I bring it to here, I've hit the fall, the autumnal equinox, back to winter, cooler temperatures. My temperatures are getting warmer as I hit spring, and again, warmest when I'm in the summer, when it's pointing towards the sun. Gravity. The force of gravity depends on two factors. Okay? The mass of the objects and the distance between them. Gravity attracts all objects towards one another. Now this is not true for energy. Energy does not have mass. Because it does not have mass, energy does not have gravity. If I increase my mass, I increase my gravity. If I increase my distance, then gravity decreases. Alright, let's look at the questions here. First off, on the graph, what two variables are being graphed here? Down here, distance from planet center, force of gravity on a rocket taking off from the planet. Question 1, what two variables are being graphed? Well, we've already answered that. Distance from the planet center, force of gravity on the rocket. Question 2, what is force of gravity on the rocket at the planet's surface? So, at the planet's surface of the planet right here, what's the force of gravity? 4 million newtons. What is the force of gravity on the rocket at a distance of 2 units, twice the planet's radius from its center? So 2 units, 1 million newtons. In general, how does the force of gravity pulling on the rocket change as the distance between it and the planet increases? It decreases. It goes down. Why does it go down? Because we're increasing distance. Okay. The changing relative positions of the moon, earth, and sun cause phases of the moon, eclipses, and tides. We always see the same phase of the moon because the moon rotates and revolves around the earth at the same rate. The phases you see depend on how much of the sunlit side of the moon faces Earth. Now, here you can see here the different phases. Our new moon, the unlit side is facing us. We have our crescent, our first quarter, half the moon is lit up. Then we come over here, waxing gibbous, and then a full moon on the back side. Full moon, the whole lit back side of the moon is facing the earth, so we see it. Waning gibbous, it's starting to get smaller. Third quarter, we know that it's waning because it's on the left side. It looks like half a moon. Waning crescent, and then we're back to the new moon. The entire trip around the earth takes about 29.5 days for the moon. The moon's orbit is tilted about 5 degrees relative to the Earth's orbit around the sun. That 5 degrees means that every time we have a new moon, we don't have a solar eclipse, and every time we have a full moon, we don't have a lunar eclipse. A solar eclipse only occurs when the moon passes directly between the Earth and the sun, blocking the sunlight from parts of the Earth. During a lunar eclipse, Earth blocks sunlight from reaching the moon. Tides. Tides occur mainly due to the differences in the force of gravity between the moon and the different parts of the Earth. Alright, when the moon is in alignment with the sun, we have something called a spring tide. When the moon is at a right angle to the sun, we have something called a neap tide. In a spring tide, we have the greatest difference between low and high tides, and in a neap tide, we have the smallest difference between low and high tides. Thank you for listening. If you need to go back and review any part of this video, please do so you can fill out your worksheet.